Okay, let me get you started on this and I'll come around and check. So first of all, don't forget about the AP review classes. Oh, so much fun to be had if you want to sit. Okay, so yeah, there's one today, if anyone wants to come. Now, we all know and love the first derivative test to find extreme, right? Like, if you want to find where a function has a max or a min, you get the derivative, right? Then you get your critical points. Now, critical values were the first derivative either, what are the okay, that's when you have a max or min, and it can only happen at a critical value. But a critical value, like when you first get the derivative, how do you know what values to? Well, that's for an absolute max, where it equals 0. What's a critical value? Because, critical values are the only place where the derivative could change sign. So when it equals 0, or else when it's undefined. So, if you want to find an extrema, a relative extrema can only occur at a critical value. So you get your first derivative, set the numerator equal to 0, that's when it equals 0. And then set the denominator equal to 0, that's where it's undefined. And you get these numbers, these critical values. So if your first derivative is going to change sign, it'll happen at one of those. Let's say you get two numbers. Give me two numbers. How about 0 and 9? Let's say that 0 and 9 either make our derivative 0 or undefined. So we mark them off. And then we take little test values in each of the intervals and we plug them into our first derivative. Let's say we get positives here and negatives there and positives here. With the first derivative test, when you get your critical values and you mark off your sign chart, if your first derivative changes sign from positive to negative, what do you know your function has? A relative max. And if it changes from negative to positive, a relative min. And that's usually the way we find, any relative extrema. We use the first derivative test for extrema. But I'm here to remind you that there's another test for extrema that might come in handy. And it's called the second derivative test for extrema. Let's see if you remember this. You might remember this. What do you think? Yeah. Very nice, Ryan. Yeah, what you do first is you find out where the first derivative equals 0. Because that's where your function has a horizontal tangent. Let's say you set your derivative equal to 0, and then you get, I like dealing with numbers right now. Let's say you get x equals 3. Okay, 3 made, so now you know at 3, you have a horizontal tangent. But you don't know if it's because you have a min, because you have a max, or maybe your function's just going flat for a second and then just going back up again. All you know is that you have a horizontal tangent at 3. Then, that's right, if you take that value where your first derivative is 0 and you pop that into the second derivative, and you get a positive number. So now not only do you know you have a horizontal tangent at 3, but now you know the second derivative is positive there. What's got to be going on? The second derivative is positive. So it's concave up, and you know you have a horizontal tangent. You have a min. So you would have a min. So I should say if the second derivative at that value that made your first derivative 0 is positive, you know that f has a min, a relative min, at x equals 3. If you plug the 3 into the second derivative and you get a negative number, you know your function has a relative max at x equals 3. Because now you know that the graph is concave down and it has a horizontal tangent. If the second derivative at 3 is 0, you don't know anything. You have to try your first derivative test for extrema. But it's a nice, quick little way to see. And on the AP test, you're going to see probably in tonight's homework that you might need to use this, like the first derivative test. That won't help you. In fact, today's do now is based on this one. You'll see why the first derivative test won't help you. So I go around and just take a look at your 2015 1 through 3 You are going to see if you can answer this question. Alrighty. Oh no, we're given the first derivative, a differential equation. Does everyone know what it means? Y of 1 equals 2? Yeah, the 0.12 is on the graph of this solution. We got the first derivative, and they're asking us for the second derivative in terms of x and y. We got this or what? Who wants to volunteer? And Annie. Okay, so you said it's 8x minus 2y, and then you said times 4x squared minus y squared? Yeah, because it would be times dy dx. But she didn't want to write dy dx. Instead, she said that's what dy dx equals. I mean, you could write it first and then substitute. Yeah. Yes, I wasn't finished with my right there. Yeah, thank you. Does everyone see? I usually write this in 2 steps, but I went right to it because she did it. I was like, woohoo. So you just take the derivative of the first derivative, and this would be 2y dy dx. You got to fill in dy dx in terms of x and y. Bam, full credit. Okay, now we got the second derivative. We don't have to simplify anything, right? Is there a relative max or min at x equals 1? How would the second derivative help us? Okay, second derivative test. First, we got to make sure that the first derivative is, what does the first derivative have to equal to 0? All right, let's see what the first derivative is. Let's evaluate the first derivative at that 0.12. Okay, so what do you think? We're going to plug in, what are we plugging in for the x? 1, of course, and then 2 for the y. No calculators. Does it equal 0? Get out. Okay, so right now, we know we have a horizontal tangent. We know the slope of the tangent line is 0. But we want to know if we have a max or min. Now, do you see why I couldn't use the first derivative test to see if you have a max or min? How would you even know, like, like if you find out where the first derivative is 0, okay, we actually know that when x is 1. But then you'd have to know the y coordinates of other points to figure out if the derivative is positive or negative, at test values. We'd have no way. We would be so much trouble. Good thing we have this other test. Okay, so let's figure out what the second derivative is when we evaluate it at the 0.12. I had that second derivative here. Oh, that thing. Take away. Okay. So yeah, let's plug in. Here it is. A 1 into the x, a 2 into the y. Oh, we kind of already know what that turns out to be, but I'll just pretend I don't know. 4 times 1 squared minus 2 squared. Max or min or neither. I don't know. You get a positive? What'd you get when you simplify things? 8? Yeah, 8 is positive, right? Okay, so if you get a positive second derivative, what do we got there? A min. By the second derivative test. Okay, so f has a relative min at x equals 1. And yeah, we can name the test by the second derivative test. Extreme. How fun is that? Right? Comes in handy. I think the AP people, like college would kind of like that second derivative test from extreme. I feel like it, and you will see it at some point tonight. Mark my words, if you do your homework. All right, so let's see how you did on the homework. First problem. This was a calculator problem. So questions 1 and 2 on the free response, those are your calculator problems. So we got a rate problem and an area volume problem with our calculator. So I gave you the answer sheet so you can check. But when you get this problem, you'd want to store your rate in, or t in y1, your rate out in y2, and in y3 you want to store rate in minus rate out. Because that's the rate of change. That's the big one. So that'd be a good way to go. So you do that, and then the first thing they ask you is, how many cubic feet of rainwater flow into the pipe from time 0 to time 8? Did you get this one right? Did you integrate rate in? Yeah? Did you put it in your calculator right? In the calculator, if you have rate in stored in Y1, you don't have to retype anything. Alright, and this is all the work you'd have to show. You don't have to write the whole, what R of T equals out again. Just say R of T. Easier. Yeah. Oh, if they said at what rate is the amount of water changing, yeah, if you're looking for a rate of change, or if they want to know whether the amount of water is increasing or decreasing, well, no, that would just be the right, no, sorry. No, I said the wrong thing there, because that would just be whether rate in minus rate out is positive or negative. So when would you use n deriv? So that would be when you're given the rate in, because that's the rate at which the rate is changing. So that's like your second derivative. I have to see one like that. I can't think of one off the top of my head. I'm not that creative right now. Alright, let's look at the next one. Like, for this one, is the amount of water in the pipe increasing or decreasing at time 3? You want to know if rate in minus rate out is positive or negative. So, I was not thinking clearly when I wrote this. I could have even saved more time. Instead of figuring out rate in at 3 minus rate out at 3, what could I have done on the calculator? Save some time. Why 3 of 3? Because if I have rate in minus rate out at 3, why not just do that? Saving myself a little time on the calculator. I could have just done that instead. But either way, you'd get an answer of negative 0.313, whatever. So that would be decreasing because you got a negative value. Alright? So whenever they ask you if the quantity is increasing or decreasing, check if rate in minus rate out is positive or negative. Anyone get 2 of both those parts right? Woo! Oh, that's not up, is it? It's just fixing your hair? No. Okay. Scratching's good too. Getting them right is good. Scratching's good. Okay. This is the one that took a lot of work. You want to know for what time between 0 and 8 there's a minimum amount of water, or whatever, in the pipes or whatever it is. So first of all, you know that the absolute min must occur at an endpoint or where rate in minus rate out changes from negative to positive. So a lot of kids were asking me today, well, I don't understand how you know when that is. What I like to do is I like to just graph Y3, rate in minus rate out. And then I can use the graph to tell me where it changes from negative to positive. So you have to turn off your other functions by going to their equal sign and pressing enter. Make sure that your x's are right. You want to go from 0 to 8. And then you just have to see where it crosses from negative to positive. That's where the amount of water is going to have a relative min. I stored that in alpha A so I wouldn't have to type it again. But you have to write it on your paper. So either you're going to have a minimum amount of water at 0 or 8 or at 3.276, whatever it is. Now, to find the amount of water at these times, you would have to, well, at 0, they tell you you have 30 gallons or something. I forgot the units. Is this gallons? No, cubic something, huh? Cubic feet, okay. And they just wrote on top here amount of water in the pipe. That's fine. You can write whatever you want. You call it A of T. But so times 0, they told you at 30. At any other time, you're going to have to take the 30 you started with, that's the amount at time 0, and add the change in the amount of water by integrating rate in minus rate out from 0 to whatever time. So on my calculator, to figure out how much water I had at time 3.27, let's say, I just did 30 plus math 9, y3, x, comma, 0, comma, a. And that's 27 gallons. And then you want to find out how much water you have at time 8. Take your starting value, 30, and add the integral of rate in minus rate out from 0 to 8. And yeah, it's a quick little thing on the calculator. And then they said, what's the time when you have the minimum amount? So the time it has minimum amount is 3.271. So you got to figure out when rate in minus rate out is equal to 0. You can just set this equal to 0 and then write your answer, just like they did. You don't have to say, I used the graph and I looked where it changed. Okay. But I would see this up top, even though it seems like they're getting away from that a little bit. Are there other questions on this? I know this is a lot of business. Anyone get this one? You got part of it? What part gave you trouble in this one? Uh-huh. Well, you take how much water you had at time 0, which is 30, okay? And then you add the integral of rate in minus rate out from 0 to 8. Yeah. Just like when I wanted to find out how much water I had at 3.272, I took 30, the amount of time 0, and I added the integral from 0 to 3. Whatever it is, 72 of rate in minus rate out. But you integrate rate in minus rate out to get the change, and then you add that to your starting value. You'll figure out these values. Other things that you didn't get right on this you want to ask me about? Anybody? No? Well, I was trying because I know some people get confused. Like, how do you get that graph to show up? When you're looking for a 0, you just have to make sure that the y min is negative and the y max is positive, so you can see where it crosses. Because if you went from like 2 to 4, you wouldn't see where it crosses. But what's important is the x min and the x max. So you can see it. That's great. I mean, as long as it's enough where you can see where it crosses the x-axis. Okay, and then the last part, the pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow in and out of the pipe at the given rates until the pipe begins to overflow. Right, but do not solve an equation, an equals here, involving one or more integrals that gives the time w when the pipe will begin to overflow. So when the amount of water is 50. Yes, right. So you wrote t of 0. They call t. Yes, yeah, time 0. Like I could see if you said amount at time 0, but time at time 0. Yeah, you really got to put the number. Like I always like to put it like this first, so I don't forget that the lower limit is the same as that number. But yeah, you want to fill that in. So yeah, you want to know when the amount of water is going to be 50. Starting amount plus the change equals 50. Those are kind of fun. Okay, so that was the calculator. And then there was one more calculator question. Area volume. So, I don't know about you guys. When I first got this problem, I thought, let me find that point of intersection in case I need it. And when you go to graph on your calculator, if you look on theirs, you think, oh, this kind of tells me, like, for my x's, maybe I'll go from negative 0.5 to 2.5. For my y's, when I set my window, maybe negative 0.5 to 4.5. So you can get a graph that looks like their graph. So I put in my calculator and I got the point of intersection. And this is one of these things we've talked about. I don't know if we've ever done. You just leave the screen and hit store alpha A, enter, and the x coordinate will be stored. If you want to store the y coordinate of that point you just found, just hit alpha y, store alpha b. And it'll store the y coordinate of that point of intersection also. Now you've got, anytime you want the x coordinate, use A, and the y coordinate, use B. I don't actually think you needed it in this one. I thought I was doing a good thing. Yeah. Now, the first thing they ask you to do is get the total area enclosed. Did anybody do it with one integral? I know the answer key shows 2. There is a way. You want to get all that area, the area of R and S together. There's a secret. Something you could do. Yeah. Yeah, you can. Yeah. If you did that? Did you really do that? No. You just thought of it now. Yeah, they didn't say it on the answer key, but instead of breaking it up, you can integrate from 0 to 2. If you take the absolute value of y top minus y bottom, it doesn't matter which one's on top. It'll always be positive. But you would have to take the absolute value of one of them minus the other. So you could have done it with one. But the normal way to do it is you get the area of R. So for R, y top is g of x, and y bottom is the f of x. So area is easy. You just integrate y top minus y bottom dx. So smallest x to greatest x, so from 0 to a. And that gets you the 0.997. That's the area of the first region. And then to get the area of S, you do its y top, which is now f of x. See, they flip-flopped. Minus y bottom. So you're integrating f of x minus g of x, y top minus y bottom, dx from a to 2. That region. Altogether, 2.004. Anyone get that one right? Ooh, got a couple more hands now. That's good. Feels good. Yeah, and then you could, yeah, I was even showing how you could do it on the calculator with the absolute value. But I don't know if you want to pursue that. As far as the work goes, this is all the work you'd have to show if you did one. All right. Hard to beat. Region S. So just region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume. That perpendicular to the x-axis is important because it's showing you which way your slices go. So does it make it a dx or a dy problem? Dx. If it's perpendicular to x, it's dx, and that means for your limits of integration, we want to go to from smallest x to greatest x of the region for S. So from A to 2. So yeah, for this type, known cross sections, you just integrate area times thickness. Once you know it's dx, you got your limits of integration. You fill in the area of a square. That's the side squared. Then as far as the length of the side, that's the length of your strip. No matter what it is, if it's a hypotenuse, if it's a leg, I don't care what it is, you're going to get it. It's y top minus y bottom. So y top over here is the f of x. And y bottom over here is the g of x. So the length of the side is f of x minus g of x. You just don't forget to square it. I didn't show that in the calculator. I guess I should have shown that. Oh, you could do it. 1.283. Good stuff. Does anyone need me to write how you put this in the calculator? To get it? Anyway. Well, that shouldn't make a difference because when you subtract in the opposite order, it's just going to give you the opposite and you square it. So you should luck out. I wonder if you threw a pi in there or you did something like that. Or if you forgot to square it. Yeah. I mean, it should be just when you do the math 9. I forgot which one I have in which, but you'd have to open the parentheses for the squaring. y1 minus y2 squared, comma x, comma a, comma 2. So far not so bad, right? It's area, known cross section. I'm kind of waiting for washers or discs, aren't you? It doesn't happen. I forgot what this. Oh yeah, this is like a little weird one. They say, okay, let h be the vertical distance between the graph of f and g in region S. So remember over here, up here you have the f of x for this region, and the lower one is g of x. So h of s is the distance between this graph f of x and g of x. How would you get it then? What does h of x equal? of x minus g of x. Okay, so h of x is f of x minus g of x. And they ask us for the rate at which h changes. The rate at which something changes is its derivative. So h of x is just f of x minus g of x. So we want the derivative of h when x equals 1.8. So we want h prime of 1.8. So if we've got these stored in our calculator, if I have f of x stored in y1 and g of x stored in y2, I just have to find the derivative. Rate at which something changes is the derivative at 1.8. And that actually makes sense that we're getting a negative value, because if you're over here, right, like that distance would be increasing, and then it should be decreasing when you're over there by 1.8. Yep. Questions? I'm thinking I know what that question was saying. All right, part D. No, not part D. That was it. Okay. Now we throw the calculators away because it's number 3. It's a table problem. Love it. First question is approximate the derivative at 16. What do we use to approximate the derivative with a table? Slope formula. Now, don't pick any 2 points. Oh no, you'll get it wrong. If they ask you to approximate the derivative at 16, you've got to choose those 2 points. Right? Because 16 is between 12 and 20. You guys get 5? Yeah? Yes. Yeah. No problem. Did you get that back there, Brian? Yeah? Nice. Okay. Next one. Using correct units. Yeah, don't skip over like the whole part of this question. Like, make sure you're reading it. Using correct units, explain the meaning of the definite integral from 0 to 40 of the absolute value of v of t. When you integrate the absolute value of the velocity, what do you get? Distance. So as far as explaining the meaning, this is going to give you the total distance traveled from time 0 to time 40. If you just integrate velocity, what do you get? Displacement. But when you integrate the absolute value of velocity, you get distance. And so that's just knowing that. Now, they want us to actually approximate this. Oh, and units for a definite integral, remember we multiply them? So you multiply minutes times meters per minute, you just get meters. So it gives you the total distance in meters traveled from time 0 to time 40. That's what it means. Now we actually have to approximate it. Now the only thing you might have messed up on here, well, probably there are lots of things you're going to mess up on, I guess. They did ask you to approximate it with a right Riemann sum. Is that you're approximating the absolute value of v of t. These are just v of t values. So you're going to have to use the absolute value of it for the height. So you have to do them all separately because you see how the intervals are different lengths? So your first rectangle, you have 12 times 200. That's the area of the first rectangle. And then 8 times 240. And you're going along fine. This is the one I didn't know if you would get because it's the absolute value. It would be 4 for the width, but for the height, because we have to use the absolute value of it, we'd have to write 220. So this one you might have got off and not might have thrown you. Then I bet you got the last one. The last one correct. All right. So that'd be 16 times 150. Now, on the AP test, stop right there. Right there. You're all done. Right? Because if you make a mistake with the math, you're going to lose the point. What's that? You said something. Ellie's talking. She's saying something trash. I don't know what it is. But then, you know, for these, you want to see if you got it right. So, of course, you carry through and you get the right answer. We love those, don't we? Good times. Okay, so we approximate the derivative with the slope formula. We approximate the definite integral with rectangles. Right, sum. What? Oh, this is a typical thing on the AP exam. All of a sudden, who was that before? Johanna? What was her name again? It was Johanna. So, laughing at me. So, all of a sudden, Johanna leaves. What's going on? Audrey, accept in silence, please. Um, so Johanna left, and Bob comes in. And Bob doesn't have a table for his velocity. Bob has an actual equation. Go, Bob. This is Bob's velocity measured in meters per minute. Okay? So don't get like hung up. Oh, what happened to Johanna? No, she's gone. Just deal with it. Bob's here. And then, so you have Bob's equation for velocity, and they want to know Bob's acceleration at times t equals 5. If you have velocity, how do you get acceleration? Take the derivative. I was going to say, you have a calculator and derivative, but nope, you don't. So you actually have to take the derivative. Remember, B of t is the Bob's velocity, so you actually have to take the derivative yourself, but you can handle it, and plug in the 5. Maybe we'll leave it like this. Maybe. Maybe we don't want to risk it. That's it. It is scary, I know. But that I know you can do. And so the units, was that? Did you remember your plus C? Oh. So I don't even know what you have there. Okay, well. Alright, so that wasn't so bad, right? Alright, and then, well, no, it was for you, but and then the last one, remember, they gave you Bob's velocity, and they want Bob's average velocity. If they give you a function, hey kid, here's a function. Find the average value of it on the interval from A to B. Is that the slope formula or the one with the definite integral? Definite integral. Okay? So it's 1 over B minus A, that's where the 1/10 comes in, times the definite integral of the function. This is where you got to take the antiderivative. Oh, okay. So yeah, you have to take, and this is no calculator, you actually have to take the antiderivative yourself, plug in the upper limit, the lower limit, and subtract. So hey, you're leaving it like this, kids. Right there. Because you plug in the upper limit, you can handle powers of 10. But then you could leave it 10 to the 4th minus 2 times 10 cubed plus 300 times 10. But really, I think I don't know. Just don't make a mistake. That would be it. That's the average value. Just don't want to do that slope formula. If they said what's the average rate of change of Bob's velocity, then you would use the slope formula. So, what did we think? Yeah. So tonight's 3, no calculator. Yeah, because for 4, 5, and 6. So tonight you're going to work on that. And there is, can I just show you something that might frustrate you? Like slope field, so easy. Then, what did it say? Get the second derivative. You guys can do that. You'll have to think after, but you can handle that. Now, the hardest one on here. Oh, this is the do now, the part C. Doesn't have a max or min there. Well, you'll get the second derivative. Part D of number 4. I just wanted to bring your attention to it. They're not asking you to solve it. You could not separate and integrate this. Do you see that? Because it's subtraction. You can only separate when it's multiplication or division. So kids who had it were like, oh no, I can't separate it. What's wrong with me? And they kept trying to separate it. No, they're saying, oh no, we already separated and integrated. We did it all for you. Here's the solution. Here's the solution. And remember, the solution has to go through that point. So if you plug in a 2 for the x and a 3 for the y, you'll have one equation with 2 unknowns. But you also know what the slope of the solution is. What is the slope of the solution always equal to? The derivative, which happens to equal, if you look at this, what is the derivative of this solution? M. So dy dx is just equal to m. So you also know for this point, x, y, what the slope is. You know what m is. And if you know what m is, you can figure out b. Let that stew in your brain and figure that out. So it's not going to be, they're not asking you to find the particular solution. They said, we found it. You figure out the m and the b in our solution. Crazy. Yeah. Yep, exactly. You got to figure out the m, and then you can figure out the b. Because so interesting, right? Of course. Oh, and this was, you're going to love it. Make sure you read it. They give you the areas of these regions. So just get out of town. Max, min. Oh my gosh. Concave up. Give me a break. First derivative. Oh, this is all easy stuff. I can't read it. It's just too blurry. Oh, if you have these areas and they gave you a starting value and you got the derivative, f of b equals f of a, you know that stuff? I'll let you think about that. See, here's your real differential equation problem, but you know what's weird? They never asked you to separate and integrate, I don't think. They never asked you to find the particular solution. Write an equation of a tangent line. You'll see it. Have fun with it, and don't forget I'm here after school. Never forget.